Okay, this is going to be the pre-calculus lesson on domain, range, increasing, decreasing, end behaviors, x-intercepts, y-intercepts, a whole bunch of stuff. I want to start with some concepts before we get to the graphs. And the concept of domain, okay, we talked a little bit about that with points, but let's talk about it with the function. What domain really is your smallest x to your biggest x. Okay, range, okay, is smallest y to biggest y. Okay, now, in order to find the domain and range, you're going to have to label a few things. You're going to have to label, number one, your arrows. Okay, this is a concept from Algebra 2. You have to label endpoints if you have them. Okay, and you have to label minimums or maximums. Okay, you got to be able to label those in order to find the domain and range of a graph. Okay, all right. So I want to do just some examples of domain and range. Okay. Okay, so let's start with, let's say we had an example that looked like this. Okay, all right. And it's not really important you graph this. I'm sort of just going to find the various pieces of information. Okay, so what I want to do is I want to label this arrows. We talked about that in a previous lesson. That's a left arrow, and it's going down. Okay, got no other arrows. When my graph ends in an endpoint, that would be 5, comma 1, 2, 3, 4. Okay. All right, then I'm going to look at minimums and maximums, local minimums, local maximums. So like here's one, we're just going to estimate that at about 0, 1. And then we got one about right here that's negative 1, 2, 3, 1, 2, 3, 4, 5, 6. So negative 3, 6. So I got all of my points here, okay? Got all of my points. So when I find the domain, I look at all the x values and figure out which one's the smallest. That is negative infinity. Talked about this last time with interval notation. When you got an infinity, it's got the curve. The biggest x value is 5. And since 5 is a closed point, I put a bracket like that. Okay? My range. Now I'm going to look at the y values. Okay? My smallest y value of all those is negative infinity, and the biggest one is 6. And since 6 is at a point, it would be a closed bracket. Okay? Let's do one more example. Okay? Let's do one more example. Let's say we got something like this. And you can just rough sketch this, not overly important that it's 100% accurate. Okay, let's say I had something like this. Now, I have no arrows involved here. Okay, so I got to label these endpoints. That's negative 7, 1, 2, 3, 4, 5, 6, 7, 8. So negative 7, 8. And then this one ends at 1, 2, 3, that's 8, negative 3. Okay? I got some of these local maximums and minimums. This is a minimum, 1, 2, 3. So that's negative 3, negative 4. This is negative 1, 3. Okay, this is 4, 3. I already got that. Okay, So if I do the domain here, my smallest x value of all of these things would be -7. Since that is in an open circle, it would be a curved bracket. What's my biggest x value? Biggest x value would be 8. And that's going to be in a curved bracket because that's also an open circle. My range, okay? Now I'm looking for y values, okay? The smallest y value here is -4. Since that is at a closed circle, that's what I would have there, okay? All right, and then my biggest y value is also going to be 8. Since it's an open circle, it would be like that, okay? Now, let me have you guys do one. And then we'll go over it. Okay, so rough draw this picture. Okay, so go ahead and sort of draw that picture. You can estimate the points to a certain degree. I've drawn them pretty good. If you want to just write out your answer, you can. Okay, if you want to find domain and range. Okay, so take a minute and do that. And unpause the video. I would label my arrow. This would be a right arrow, infinity, infinity. Okay, right arrow going up. This is an endpoint, -6, -1. This is -1, -2, -3, -3, 5. This is 0, -2. This is 4, 5. And this is 7, 0. Okay? So if I look at what's the smallest of all the x values, -6 would be the smallest. What's the biggest of all the x values? That would be infinity. Okay? From a range standpoint, the smallest y value is actually -2, and since it's at a point, it would be like that, and the biggest y value would be infinity, okay? So that right there is domain and range. That's a big concept, okay? All right. Let me talk about a couple more concepts. Okay, I'm going to go back to, I'm going to stay on this graph right here. I want to talk about the concept of increasing, decreasing, and constant. Okay? Now, the idea behind increasing, decreasing, constant is if you've labeled all the stuff for domain and range, you're good. It's easy. Okay? Now, for these things, we want, for increasing, decreasing, and constant, we want x values only. Okay? All right? We want x values only. Okay? As far as the interval part of it, as far as these brackets, it's not as important to be accurate with whether they're points or not, and I'll explain that in a second. Now, we want x values only, and we start from the left and trace the graph. Okay? So we're going to start from the left, furthest left point, which was here. Okay? And I'm going to trace the graph. If I feel like my pen is going up, that's an increase. So this is increasing. Then I get to here, and this falls like that. That's a decrease. Okay? Then I go up like this. That's an increase. Then I go down here. That's a decrease. And then I finish through here. That's an increase. Okay? Always start left to right. Now, what I mean by we only care about the x values, these are the only values I care about. Okay? I won't be as picky grading your brackets for interval notation. If you wanted to say, well, Mr. Evans, that's a -6, I'm starting at -6, that's fine, you can use that bracket. Okay, I'm going to -3, all right, I'm going to put a curved bracket. So we say, Mr. Evans, but that's a point. I've seen textbooks do it two ways. I've seen people consider that a square bracket. I've seen curved. I'm not going to be picky there. Okay? Then from -3 to 0, I'm decreasing. Then from 0 to 4, I'm back to an increase. Then from 4 to 7, I'm decreasing. And then from 7 to infinity, I'm increasing to finish. Okay? And that's how you do increasing, decreasing. Okay? All right. Let's do another example. Okay? Let's do another example with increasing, decreasing. Okay? All right, let's say I had something like this. Fill that in. That's open. Let's say I had that. Okay? So same concept. All right, I want to do increasing, decreasing, and constant. Okay? All right? So what I have here, okay, if I label these, okay, all right, I'm going to label this arrow, that's infinity, negative infinity. This endpoint would be -7,5. This would be -4,1. And this would be 2,1. Okay? All right? So, all I care about are the x values. Okay? Furthest left part of the graph would be here. So if I trace my pen, that's going down, that's decreasing. Now this is flat, that's going to be constant. And this going down, that's a decrease. Okay? So there is no increase here. First value, -7 to -4 is a decrease. -4 to 2 is constant. And then 2 to infinity would be a decrease. You can have some of them and not others. Okay? All right, so that's an example. Okay? All right? The next part I want to talk about, I'm going to insert the page after this current one. Okay, I want to talk about x-intercepts and y-intercepts. Okay, we'll do some applications in a second with all that other stuff. Okay? All right? So the concept behind an x-intercept and a y-intercept. Let's say you had something like this. All right? And we'll just say that crosses at -2. Let's say that crosses at -6. Let's say this crosses at -5. And let's say this crosses at 4. Okay? All right, now, I think everybody knows an x-intercept is where it crosses the x-axis. Okay? Another way of saying x-intercept, the same thing, are zeros, roots, solutions. All of those mean the same thing. Okay? So in this case, this crosses the x-axis at these 3 points. So my x-intercepts here would be x equals -6, x equals -2, x equals 4. Okay? My y-intercept is where it crosses the y-axis. Okay? Nothing overly complicated there. So my y-intercept would be y equals -5. So you just use the letter. Pretty simple stuff. Okay? All right? All right, now, we're going to put all this stuff together. Okay? Let's say we had this picture. Let's say we have this, and here's what we're going to find. We're going to find domain, range, increase, decrease. We're going to find our we'll do constant too. X-intercept, y-intercept, and we're also going to answer these two questions. X approaches infinity, y approaches blank, x approaches -infinity, y approaches blank. We talked about end behaviors last time. Okay? So what I want to do is label. This is an arrow. Left arrow, -infinity, going up, +infinity. This is a right arrow. It is going up, +infinity. Okay, pretty easy. All right, label these points. Okay, -2, 1, 0, 5, 2, 0. Okay? All right? So, if I'm doing the domain, all right, the smallest x value of everything I've listed is negative infinity. The biggest is positive infinity. That's the same thing as saying all real numbers. My range, my smallest of all the y values is 0. And since it's at a point that's there, the biggest would be infinity. Curved bracket. Now, let's do the increasing, decreasing. I start from here. This would be a decrease, then it hits the increase, then decrease, then increase. Very important you go left to right or it doesn't work. Okay? So, from negative infinity to negative 2, I'm decreasing. From negative 2 to 0, I'm increasing. 0 to 2, I'm decreasing. 2 to infinity, okay, I'm increasing again. There is no constant, that is none. Okay, my x-intercepts, where does it cross the x-axis? The only place it crosses the x-axis is right there. So that's going to be x equals 2. The y-intercept, where's the only point that crosses? That's going to be y equals 5. Okay, and then answering these questions, as x approaches infinity, the y-coordinate there is positive infinity. As x approaches negative infinity, the y-coordinate is also infinity. Okay? All right, let's do one more example, then I'm going to give you guys one to do on your own. Okay? All right, let's say I got something like this. Okay? All right, and we're going to find domain. We're going to find range. We're going to find increase, decrease, constant, x-intercept, y-intercept, and we're going to answer these questions here. Okay, so I'm going to label my arrows. That's a positive infinity, positive infinity. This endpoint is negative 6, negative 6. Okay, this point would be 0, 4. This point here would be 7, negative 3. Okay, so if I look, I've done all that. Domain smallest of all the x values would be negative 6. Since it's an open circle, I put that. Biggest one would be infinity. My range, my smallest is also negative 6. And my biggest is also infinity, okay? Okay, so from the increasing, decreasing, all I care about are these. As you notice, I didn't label the intercepts. I don't need the intercepts, like where this crosses here at 4, I don't need that to do these first things, okay? So tracing, this would be an increase, then it's a decrease, then it finishes with an increase. So it's increasing from negative 6 to 0, then decreasing from 0 to 7, then increasing from 7 to infinity. There is none, all right? X-intercepts, where does it cross? It crosses here, and crosses there. So it crosses at x equals negative 3, x equals 4, and x equals 8. Okay, where does it cross the y-axis? Crosses the y-axis at 4, y equals 4. All right? So x approaches infinity, y approaches, okay, so this is the x is infinity, that will be the y. Now watch. X approaches negative infinity. I don't have an x with negative infinity. So this would be none. There is none there, okay? All right, so sometimes you don't have the end behavior. All right, okay, let me give you guys a graph to do on your own. And I'll talk about one more thing and then we're done with this lesson. Let's say, you go here. Actually, let's scrap this. I like this one. Let's move this thing. right, so here's what I'd like you to find. Okay, you can estimate that right at that line there. I want you to find the domain, range, increasing, decreasing, constant, x-intercept, y-intercept, and answer these two questions. Okay, so go ahead and pause your video and go ahead and figure that out. Okay. All right. Now you can unpause. As you can see, I have no arrows here. I label this as -3, -2. I label this point, I'm going to say 0.5, -0.5, comma 4. Okay. All right. I'm going to label this point 6, -8. I'm going to label this point 10, 5. Okay? So for domain, my smallest x value is -3. And my biggest x value would be 10. And since that's in a closed circle, I put that. My range, my smallest y value is -8 at a dot. My biggest one would be 4. Okay? Also at a dot. For increasing, decreasing, all I care about are these. Okay, so it is increasing from -3 to -0.5. This would be an increase, decrease, increase. All right, to 0.5, or -0.5, and then from -0.5 to 6, I'm decreasing, and then from 6 to 10, I'm increasing. All right, there is no constant. Where's it crossing the x-axis? That's -2.5. X is 1.5. That's 1.5, and that's going to be 8. The y-intercept is crossing at 3. Now, x approaches infinity. I don't have any arrows. Both of these answers are none. Okay? All right. Let's go on to the last concept. It's something we talked about. Okay? Let's say I have something that looks like this. Okay, all right, so we're going to find the domain. Domain, okay, range. You can see that domain thing, yeah, that's good. All right, increasing, decreasing, constant, x-intercepts, y-intercepts, x approaches infinity, y approaches what? X approaches -infinity, y is what? Okay, and the last thing we're going to talk about is what is the rate of change between -4 and 5. Okay? All right? Now, to a certain degree, nothing changes here. Okay? This arrow, negative, positive. This is a positive, positive arrow. Okay? This would be -4, 1. This would be -2, 7. This would be 2, 1. And that would be good enough. Okay? So the domain, my smallest x value is -infinity. The biggest x value would be infinity. Okay? So if you need to label x, y, x, y, x, y, x, y, x, y, if you need to do that to get it right, do that. Okay? And then the range, my smallest y value, I have a tie, it's 1. So I'd have 1 there. My biggest would be infinity. If I trace my pen, this is a decrease, then goes increase, then goes decrease, then goes increase. Once again, all I care about are the x values here. Okay? So it's going from -infinity to -4 on a decrease, -4 to -2 on an increase, -2 to 2 on a decrease, and then 2 to infinity on an increase. It's not constant. Okay? X-intercepts doesn't cross the x-axis, so the answer would be none. The y-intercept, it crosses right here at about 1, 2, 3, 3.5. As x approaches infinity, y approaches infinity. As x approaches negative, that also is going to be negative. Okay? Now, we talked about this in another video about rate of change. Concept being from -4, so this is an x and this is an x. So at -4, I'm at -4, 1. At 5, I got to estimate that. At 5, I'm right here at 5, 7. Okay? So what I want to do, this is like your x1, y1, all right, x2, y2, okay, from our slope formula. Okay? So slope formula, y2 minus y1, x2 minus x1. Okay, so 7 minus 1 over 5 minus -4. Okay, so that's going to be 6 over 9, which would end up being 2/3 would be the rate of change. Okay? All right, let me give you guys one of those problems to do on your own, then this lesson is done. As soon as that gets done. Thinking. All right, great. Okay, there's my picture. All right, I would like the domain, the range, the increase, the decrease, the constant, the x-intercept, the y-intercept, x approaches infinity, y approaches blank, x approaches -infinity, y approaches blank, and then I want the rate of change between -3 and let's say 7. Okay, so go ahead and pause your video and work on that. Okay, you can go ahead and unpause. So I'm going to label my arrows. This would be a positive arrow, positive, negative. No other arrows. This would be -6, 1, 2, -3. This would be 1, 2, 3. This would be 3, 7. This would be 0, 2. This would be 4, 10. All right, and that's it. Okay, so my smallest x value here is going to be -6. My biggest x value would be infinity. Okay, curve because it's an open circle. Range, my smallest y value is -infinity. My biggest one is 10. Also that. All right, now we're going to do the x-intercepts. I'm sorry, the increasing, decreasing. Okay, start from the left. This is an increase, decrease, increase, decrease. Okay? All right, so it's increasing from -6 to 3, decreasing from 3, sorry, that should be -3. From -3 to 0. Then it's increasing again from 0 to 4, and then decreasing from 4 to infinity. Okay, it is not constant. Okay, so it's none. My x-intercepts, I'm going to estimate that x-intercept at x equals -5, and I'm going to estimate that x-intercept at x equals 7. My y-intercept crosses there at 2. Okay, as x approaches infinity, I have one of those, the y is negative. As x approaches -infinity, I don't have one of those, so that's none. Okay, the rate of change from -3 to 7. Now I hope that didn't confuse you. This right here would be 7, 0. So these are x values, x, y. So we'll do this as x2, y2. This will be my x1, y1. Okay, so as I do my slope formula, y2, y1, x2, x1. So -7, 7 minus -3 would be 10, and that would not reduce. That rate of change would be -7, 10. Okay, so that gives you a good idea of all the function properties. A lot of our characteristics, a lot of those are review. Okay, and we'll move on to the next lesson.